Hello. Okay, so welcome back to this live stream. I'm so sorry for what happened. At times we get challenges here and there. Great. Now, ladies and gentlemen, we are looking at integration. Integration is the topic of the day. I would want us to recap and look at exactly what we did for the last 30 minutes. And here I happen to be having an example which I would want us to integrate together for us to be able to master what we have done. So remember that to integrate, we said the symbol is like this. This is an elongated S standing for what here? Summation. So to integrate is to sum, is to put together. So if you're told to integrate this particular term with respect to dx, what we shall get at the end of the day will be ax n plus 1. So you add. And then remember to divide by the new power plus what here? Plus k. You divide by the new power plus k. K is the constant of integration, constant of integration. So then if you tell me to integrate this, how will this look like? For me to integrate this, remember, I will integrate one term at a time. And the power is going to increase by 1. Integration is all about increasing the power by 1. So it was 3. We increase the power by 1 to 4. We divide by the new power. Come and take on the second term. The second term here is 3x squared. So if I'm told to integrate this, I have to increase the power by 1. So then at the end of the day, we will get 3x raised to power 3. All over, in this case here, the new power, which is 3. Plus, now I'm integrating this 4x, so it'll be 4x raised to power 2 all over what? All over 2. Because remember, there is an implied what? An implied 1 there. So if you increase that 1 by 1, you'll end up getting 2 divided by 2. There is a constant here. Unlike differentiation, there are no constants that disappear under integration. So under integration, what do we have here? We have this constant here taking the variable of the function, which is x. And please don't forget, never forget the constant of integration. If you forget the constant of integration, then you will be wrong. You'll be wrong. Integration normally comes with a constant. So if I was to divide like this, 4 goes 2 times into 8. So we have 2x raised to 4 plus this and this cancels out, giving us x raised to 3. This and this gives us 2x raised to power 2 plus 3x plus k. Now, what if you are told here to integrate now this one? You are told to integrate x squared plus what here? Plus 2x. Integrate x squared plus 2x. Integrate x squared plus 2x. I expect a candidate who will be sitting for KCSE this year to know this. Or rather, even from the little example that you have done for you from AfriSchool, the online school, with the concept we have given you here, you should be able to differentiate this. Great. So just try that. We see whether you will be able to get it correctly. Whether you will be able to get it correctly. Okay, so ladies and gentlemen, if you look at this function which they want us to integrate, it's quite an easy one. We shall be able to knock it down very fast. It has got only 2 terms, and we're going to integrate one at a time. So we start with x squared, integrated, increase its power by 1. So we'll talk of x cubed, all over 3. Plus this term here, whose power is an implied 1 there. If I integrate it, I'll end up getting 2x squared over what here? Over 2. And of course, your examiner wants you to forget k. When you are integrating, ladies and gentlemen, always remember the k like that. So this and this cancels out, leaving us with x cubed over 3 plus x squared plus what here? Plus k. Plus k. Now, ladies and gentlemen, that now opens a door for us. another door for us, where we shall be able to look at this kind of a question where you are told here, look at this question, find the equation of a curve, whose gradient function is dy over dx equals 2x plus 3. And it passes through one point, which is 0, 1. This is quite popular in your exams, quite popular. So find the equation of a curve whose gradient function is dy over dx, which is like this. And it passes through, that curve passes through this particular point, Please, as we do this, don't forget to share this content with your friends on your timelines. Don't forget to share. Please ensure that you are sharing. Share this good stuff. Share the good stuff with your friends. Share the good stuff with your friends. Share the good stuff with your friends on your timeline. That is how they'll be able to get this particular good word about AfriSchool. And for those of you who may want to reach us at AfriSchool, our numbers are written up there. On that post, you'll be able to see our number 0700 220 221. 0700 220 221. You'll be able to reach us at AfriSchool using that number. So if you're told here to integrate, ladies and gentlemen, this one, what do we have? We have, if you integrate this will be, so we have here x squared plus 2x. Yeah, so if you integrate this, what have we said? This will be x cubed over 3 plus 2x squared over what here? Over 2. It's always good for us to keep on repeating these things, plus k. Very important for us to keep on doing what here? Repeating. Now, so they have given us, in the question that I gave you, they gave us the gradient function, which is dy over dx, which is 2x plus what? Plus 3. And then they have given us 1 point, which is 0 and 1. And then they want us to define the equation which starts with y. How will we do it? The equation which starts with y. So this is quite easy. What we need to do is to come and have it this way. Because I want to have y, the equation normally starts with y. So I'll make dy the subject of the formula, which is 2x plus 3, put this in brackets, dx. Now, I don't want the d small y's. I want the capital Y. So how do I get the capital Y, ladies and gentlemen? I have to come and sum the minute y's for us to be able to get the capital Y. So if I am summing this side, for the equality to hold, I must also come and sum the other side. So then at the end of the day, if I sum this one, I will get capital Y. So this is capital Y, which will be equal to, of course, if I'm integrating this, I'm summing this, so even the other side must be summed. So then remember there is an implied raised to power what here? Power 1 there. So I'm integrating. Integration is all about increasing the power by 1, and then you divide by the new power. So what do we have here? Somebody will increase the power by 1. That gives us 2. Divide by the new power, 2. Plus, I can see here they want me to integrate a constant. A constant on integration will give us what here, somebody? You take the variable of the function. The variable of integration here, we are integrating with respect to x. So the variable is the one that comes and sits there, plus our constant of integration. Always integration, you must add what here? A constant. So ladies and gentlemen, at the end of the day, what we have here is this 2 and 2 canceling out, giving us x squared plus 3x plus what? K. So here they have now given us a point. There is this point here. So whenever they give us a point, they want us to eliminate K. They want us to be able to get this K. So remember, this point is in the form of x comma what? Y. So basically they are telling us that x is 0 and the y equals what here? 1. So please come and eliminate this K by evaluating it. Give us the value of K. So our y here is 1, which will be equal to x, which is 0 squared, that is 0, plus 3 times 0, that is, of course, that will be 0, plus our K. So then this will be 1 equals 0 plus K, implying that our K will be equal to what here, my friends? 1. So meaning that at the end of the day, I have to write my equation, which will be x squared plus 3x plus 1. That is what your examiner wanted you to do. That's what your examiner wanted you to do. Great. Any question? Please ask questions, ask questions, ask questions. Ask questions. And as you ask your questions, don't forget the essence of this free class. It's basically a publicity class for us. Would want you to publicize us so that you can get a bigger audience, so that also the audience, as we benefit, the audience will also be benefiting out of our high quality teaching. Now, ladies and gentlemen, what if you are given this kind of a question? Find V in terms of H. If dV over dH equals 3H squared plus 4, and they're telling us V equals 9, H equals what? 1. So what do they want us to do? They want us to find V, and yet what I can see here is dV. So then automatically here, integration must be used. So because I'm able to see dV, come and make dV the subject of the formula. So in the solution, make dV the subject. Make dV the subject. So if you make dV the subject, it will be 3H squared plus 4 multiplied by what here? DH. So they want V, not dV. These delta values, very small values, ladies and gentlemen, if I want to make them capital V, if I want to compound them, I must come and sum them. This is an elongated S for summation. So when I sum them, I'll be able to get capital V. But you see, at the same time, if I'm summing here, for equality to hold, I must also come and sum the other side. So summing the other side means what here? You are integrating with respect to H. So if you integrate this, remember the rule of integration. The rule of integration, ladies and gentlemen, if you can recall, the rule of integration is all about increasing the power by 1. You increase the power by 1, and then you divide by the new power. Anytime you're asked to integrate any term, always remember that integration is all about increasing the power by 1 and then dividing by the new power. Let's apply this concept here. So we have here 3H raised to a new power, which will be 3. The old power was 2. Remember, to get the new power, we take the old power plus 1. Divide by the new power. So many candidates forget this concept of dividing by the new power. Plus, we have the constant. This constant, upon integration, upon putting things together, it will be able to take the variable of the function. So plus 4H. Remember, in integration, there is nothing that disappears, because actually, we even at the end of the day come and add a foreign variable. We must add K there. Right? So of course, this will mean that our V, these 3 and 3 will cancel out. Our V will be H cubed plus 4H plus k. So now the moment I get this and I realize they have given me a point, of course I know what they want. They want me to replace k. They want me to evaluate k. So v, they have told me that v is 9. So come and put 9 there. H is 1. 1 raised to power 3 is 1. 1 can never be amplified by raising. Whenever you raise 1 to any power, 1 will always remain. Plus 4 times 1 plus k. So implying that our k will be 9 minus 5, because you see 1 plus 4. 1 plus 4 is 5. And this 5 is positive here. When it crosses over the equal sign, it will be minus. So implying that our k equals what? 4. So, and if that is the case, then now I can comfortably write for my examiner the function v. I can very comfortably write for my examiner the function v, which will be h cubed plus 4h plus k, which I've been able to get as what here? As 5. Which I've been able to get as 5. Now, if you allow me, remember, ladies and gentlemen, today I'm talking to KCSE candidates. KCSE candidates, I really needed to have so many of them watching, but I can only see that we have quite a small number there. Quite a small number there watching, which is too bad. We're supposed to be having 1,000 plus, because I'm so sure there are very many students who are stranded, who don't have teachers outside there, and yet they're going to sit for these KCSE exams with some students who are privileged. So how I wish we guys could really go out of our way. I know so many people would want to be quite unseen, not seen in social media. But I would really urge you to get out of your way and tag parents that you know whose candidates, whose sons, whose children will be sitting for KCSE this year. Tag them there. And because I know that there are some children, it's against the law, but what do we do? That's the reality. There's some children who happen to be having these smartphones. They are on Facebook. I mean, if you know them, take them there. This is a very important post which they should be seeing. So please tag them there. And then, of course, the very best will be for you to share. You share this, you share. Share this on your timeline. So now, having known how to get the value of k, I would want us straight away, ladies and gentlemen, to go a notch higher to what we call definite integrals or definite integration. So definite integration, definite integration. Definite integration. Now, if you see any integration being given like this with respect to dx, this is indefinite. This is indefinite. This is indefinite. Why? Because we don't have limits. It can only be called, ladies and gentlemen, definite. It can only be called definite if it is like this. You are told to integrate this with, for instance, within these two limits here, where the lower value of x is 2 and the higher value of x is what here? Is 8. So whenever you see yourself, ladies and gentlemen, integrating and the limits are being given, then know that at the end of the day, you're going to get a definite answer. You're going to get a definite answer. So you'll get a definite, so this is definite integration. This definite integration. Definite what here? Integration. So definite integration is integration within integration of functions where we are given limits, within limits. So there is nothing really much different between these and the indefinite integration that we have been doing. What I will do, I'll come and integrate this the normal way. So remember, integration is all about increasing the power by 1. You increase the power by, so 2 plus 1 gives us 3, all over 3. This is the only term. Don't forget to come and add what here? K. And then what I'll do, I'll come and put, ladies and gentlemen, my powers, or rather my limits there. So then at the end of the day, what will we get? this 3 goes into this 3 times. So this is 3x raised to power 3 plus k. And then we have 8, we have 2 there. So because of the concept of definite, what we're going to do is to plug in the value of x. We know x is 8, and at the same time, we have its lower limit of 2. So what we shall do is to come and assume x is 8. So 3 times 8 raised to power 3 plus k. And then now minus the same function, but this time around assuming that x is what? 2. So we start by assuming that x is the higher. X is the higher. And then now minus the same function, but now this time around substituting for the lower limit. So then this will be 3 times 2 raised to power 3 plus that k. Of course, k is not known. The figures we have here, these are x values. Now, so come and take your calculator and give us this thing. So many high school students do not know how to use their calculators very well. And that is why Afri School is so good to you, because here we'll just come and zoom to show you exactly what we press to get these parameters. So the first one is 3. So on first. So we have 3 times, we have 8 raised to power. You can see this raised here. Raised to power 3 equals. So what figure are we able to get? We are able to get 1536 plus k equals 2 raised to power 3 is 8. 8 times 3 is what here? 24 plus k. I mean, this is supposed to be negative. This negative here. So then when we open bracket here, we'll get 1536 plus k minus 24 minus k. So then we'll talk of 1536 minus what? 24, like terms. So 1536 minus 24, which will give us what figure? Which will give us 1512. 1512. And then what happens to this k? K disappears. And that is why for definite integration, I would want you to take this very important point down there, that for definite integration, this definite integration, we ignore k. We don't work with it. Anytime you have limits, if you are told, for example, to find some area under the curve, and they have given you limits, always ignore k. Always ignore k. Always ignore k. Always ignore k. So ladies and gentlemen, where are we? What have we done so far? Do you have any question? If you have any question, please do not hesitate. Do not hesitate in this case here, asking, because as we keep on saying, Afri School is all about the interaction. Actually, that is what distinguishes us from our competitors. We like our competitors, but it's good to get to know the truth that for us, we really go for systems that are quite interactive. We're supposed to talk like now the students who are with us in Zoom. They'll be able to talk to us. We even pose questions to them. They respond, they do, and we are even able to see exactly what they have done. Now, so if there are no questions, I would want us to do what we have done, but this time around, by looking at a small question here. If you are given this one here, you are told to integrate x squared minus 6x plus 5 within what limits here? 5 and 1. So x equals 1 and x equals what? 5, like that. So it's a definite integration, not a problem. What I will do, I will come and integrate this. Integration is about increasing the power by 1. So then we'll talk of x raised to power 3. It was 2, now I've increased it by 1. Divide this by the new term, which is 3. Minus, this had an implied 1 there, but now that they want us to integrate, I'll come and increase the power by 1. We divide in this case here, of course, I've gotten the new power there as 2. I divide by the new power. For integration, ladies and gentlemen, this constant will not disappear. So we'll talk of plus 5 what here? X plus 5x. plus 5x. Anytime you see a constant and you're told to integrate, always bring the variable of integration to that term. It was a constant 5, but now upon putting together, upon summation, I've been able in this case here to add the constant of integration, or rather to add this variable of the function into this. Now, I would have very easily said k, but on looking at these things the second time, I'm able to see that this one here, I should disregard k. Why? Because I can see that I'm integrating within the limits. So ignore k, because either way, I even showed you from the first example, either way, we're going to have that k doing what here? Canceling out. So come and put here 5 versus 1 there. So this will give me 3. So please go ahead and evaluate by putting the upper limit. So the upper limit will be 5 cubed. If you assume x is 5. So 5 cubed over 3 minus this is 3 times 5 squared plus 5 times x, which is what here? So upper limit. So first of all, you handle the upper limit. So the upper limit gives us an answer. And then we have the lower limit. So the lower limit, what do we have? The same function, but this time around you're inserting 1 in the place of x. So we have 1 raised to power 3 over 3 minus 3 times 1 squared plus 5 times 1. So then what you need to do is to come and get a calculator. So a calculator, what do we have here, somebody? It is 5 raised to power 3. 5 raised to power 3 divided by 3 minus 3 times 5 squared. Yes, plus 5 times 5, which at the end of the day gives us minus 8.33. So minus 8.33. It's good to repeat again. So we have here 5 raised to power 3 divided by 3 minus 3 times 5 squared plus 5 times 5, which gives us minus 8 point what here? 333, like that. And then we have here, of course, 1 cubed is 1 divided by 3 minus 3 times 1 squared plus 5, which gives us 2 point what here? 333. 2.333, like that. Now, of course, they want, ladies and gentlemen, us to evaluate, to give them a definite figure. So for us to give them a definite figure, what do we have? It is minus 8.33 minus 2 point what here? 33. So we have here minus 8.33 minus 2.33, which will give us minus 10 point what here? 66. Now, of course, when we'll be going to the areas and the curves, you'll see us ignoring these negatives, because you can't have a negative area. But for now, they simply wanted us to evaluate, which now takes us to the second concept, actually not second, third concept of the day. Third concept of the day. This is getting better, and that is why really I'm urging you to share it on your timelines. You share, just share. I mean, you don't need any much efforts really for you to share this. We want this good word to get to our friends. So the next thing there will be the area. The area under curves. Area under curves. Area under curves, we basically use definite integration approach. Use definite integration approach. So for instance, ladies and gentlemen, you'll be told here to find the area. Find the area of the region, bounded by the curve. Bounded by the curve y equals x raised to power 3 minus 3x raised to power 2 plus 2x. The x-axis, that's comma, the x-axis, and where x equals 1, and lastly where x equals what? Just big phrases here for nothing. These are very simple area. Getting area under a curve, ladies and gentlemen, getting area under a curve, they simply want us to integrate. So they want us to integrate this, which is x cubed minus 3x squared plus 2x plus 2x. So we integrate it within the limits of x. So where x is 1 and a 2 like that. Of course, I'm integrating this with respect to what here? With respect to x. I'm integrating this with respect to x. So could you kindly integrate this for us? Integrate this for us. Integrate that for us, and the good students should be able to give us an answer as a comment there on Facebook. Comments, you simply go to, after you get an answer, you can even take a photo of it. And then you post that photo on the comments section, And ladies and gentlemen, as we do that, don't forget the essence of this thing is sharing. So this is the question that we are doing. There's a question that they're doing here, this question where they wanted us to give them the area under a curve. The area under the curve. So then what do we have here, ladies and gentlemen? What we have here is quite simple. So come and integrate this for us. When you integrate for us, what do you have there? We have here x raised to power 4 over 4. Because integration is all about increasing the power by 1 and then you divide by the new power. Minus, we have here 3x raised to power 3. Divided by 3. Plus, so this term here, when you integrate it, you'll get 2x raised to power 2. You know, the way it is, there is a power 1 there. So increasing the power by 1, we'll end up getting what here? 2. Divide this by what here? By 2. I'll not add a constant of integration because here there is the concept of a definite. They want a final answer. So I'll talk of 1 versus 2 there. 1 versus 2. 1 versus 2. So ladies and gentlemen, if that is the case, I can see this is the 2 canceling, even these ones, like that. So then what we need to do is to come and plug in the upper limit. So plug in the upper limit. So by assuming that x is 2 alone. So what do we have here in the entire function? Taking x is 2 in the entire function. So we have 2 raised to power 4 divided by 4 minus 2 raised to power 3. There's nothing really here because 3 and 3 canceled there. Plus, so we have 2 squared. So give us an answer. And then you come and again assume this time around that in the entire function, we have the lower limit. So 1 raised to power 4 over 4 minus 1 raised to power 3 plus we have here 1 squared. Get an answer. Get an answer. So what do we have here? We have 2 raised to power 4 divided by 4 minus 2 raised to power 3 plus 2 raised to power 2 equals. So the upper limit, I'm able to get, if I substitute, I'm able to get 0 there. And then this other lower limit, it's 1 raised to power 4 divided by 4. Please remember that this is a power. It's a power. Divided by 4 minus 1 raised to 3. 1 raised to anything is 1 plus 1, which at the end of the day gives me a quarter, or what here? 0.25. 0.25. 0.25. So in this case here, this 0 minus 0.25 gives me 0.25. When you see this being a negative, automatically tells you that the area you are getting is an area which is below x-axis. So the area is the one that is below x-axis. And if it is below x-axis, ladies and gentlemen, then what you're supposed to do is to disregard the sign, because the area can never be negative. So if it's area under the curve, whenever you get negatives, always forget about negatives. Disregard the negative sign, and therefore the total area will be what here? 0.25, 0.25, 0.25. So I hope you guys have enjoyed our class today. I don't know whether there is anybody who has a question. Anyone who has a question? So if you don't have questions, my friends, I would want just to tell you something small about AfriSchool. What we do over here, we simply teach children, primary school children. We have in this case here secondary school students, all the subjects. And then we have now college students. College students, in this case here, we teach them all the CPA courses. We have ATD, we have CAMS courses, we have NEC, all the TVET courses, business courses, TVET business courses, all of them will be able to get them where? At AfriSchool. And our rates are very subsidized. We only charge Kenya shillings 3,500. And the moment you pay us that amount, we shall be able to give you access to quite a huge chunk of very relevant information. We shall be able to give you access to our pre-recorded videos. So once you pay Kenya shillings 3,500, we'll give you access to our pre-recorded videos, and then we have what we call the smart notes. These are highly condensed, but very, very efficient, very, very reliable notes that you can use for you to pass. So smart notes. And then we have in this case here, what we call live classes, what we call live classes. So I hope you really enjoyed, and I don't know whether there is anybody who has any question. So if you don't have any question, please don't forget, my name is Dr. Joshua Aura. Dr. Joshua Aura is an author. I've written over 30 books of CPA. So for the high school students who will be transitioning to college and you would want to use CPA materials, don't forget our brand name is RCM. It's RCM. This is where I happen to be the principal. I would want to take this opportunity to welcome all of you there one of these fine days. But most importantly, given the COVID, we are studying all of us online, so that we stay safe. This corona is not a joke. Otherwise, thank you very much. Have a happy Sunday, a happy Palm Sunday.